All right, this is HPC Quadratics Notes Part 2, the long version it looks like. All right, so going on with number 3 here, we're graphing parabolas. Parabolas are the shape, quadratics are the name of the equation, right? And this one looks like it's in, let's see, what was that form called when it's got everything over on one side? We're not in vertex form, we're in standard form. Okay, so this is standard form. So let's go take a look at this one and see if we can get it done in standard form. So what are the big things I need in here? I need to make sure it's in decreasing order. So I have an x squared, a single x, and then the number. The number does not belong on the other side. Everything is here. And so I just want to identify what all those are. So a is 2, it's the number in front of x squared. B is 14, it's the number in front of the single x. C is 20, and again, that's only when it's over with the x's, that it's a 20. Don't move it over on the y side. All right, so again, the first thing I'm going to want to do here is I'm going to want to find the vertex. And in order to find the vertex, I'm going to have to do negative b over 2a equals. So I'm going to do negative 14 over 2 times 2 equals negative 14 over 4, which is negative 7 over 2. Well, that stinks. I don't want to do negative 7 halves. That sounds horrible, but that's where we are. So let's go do it. Okay, so negative 7 over 2. And then to figure out the other part, I'm going to have to plug that in, you guys. This is horrible. Who wrote this? I think it's Miss Mitchell. We're going to blame her. Okay, so negative 7 over 2 squared plus 14 times negative 7 over 2 plus 20 is going to give us 2 times 49 fourths plus, I can reduce this a little bit and make this 7. So minus 49 plus 20. And then on this one, those are going to reduce a little bit, and I'll get 49 halves minus 29. So how much is this? This is 24 and a half minus 29. So let's see, so that would be negative 4 and a half, I think, right? If I put in that much and add it to that, I would get, yeah, negative 4 and a half. Horrendous, how horrible. And what is that as an improper fraction? That's negative 9 halves, I think. Blech. All right, so negative 9 halves. That was awful. Okay, so that's negative 3 and a half and negative 4 and a half. So negative 3 and a half is right here. Negative 4 and a half is right here. So I'm putting a dot right here to start it, right there. Whew, that was a lot of work. I'm not a fan of this problem. All right, let's go see what else we can find. All right, so if we did that, we already know the axis of symmetry. We already know that it is x equals negative 7 halves, and that it goes directly through this entire thing to get to that vertex. Okay, and then the next thing is finding x-intercepts. Well, to do that, you set y equal to 0. And if I put y equal to 0 here, I am stuck doing factoring. So this is not going to be a fun problem at all. So if I set this equal to 0, I'm going to get 0 equals. And then looking at this equation, I can see that each one of these numbers is divisible by 2. So I'm going to pull a 2 out to the front. I'm going to undistribute a 2. So it's x squared plus 7x plus 10. Okay, and then I'm going to see if I can possibly factor this. So can you think of two numbers that multiply to make 10, but add to make 7? Yeah, a 5 and a 2 should work, but only if they're both positive. All right, so when something's set equal to 0, remember that concept about either one or the other. Either this equals 0 or this equals 0. They don't both have to equal 0 at the same time. And 2 cannot equal 0. That's just an impossible statement. So you get to just kill off that 2. We don't need it anymore. Okay, so the two x's I'm going to get x equals negative 5, and I'm going to get x equals negative 2. So negative 5 and negative 2 are going to be my two answers for my x-intercept. So negative 5 and negative 2. Do those look symmetric along the axis of symmetry? They do, so we're doing good there. Oh, please make it a little bit easier. Come on. Okay, finally, y-intercepts, I get to set x equal to 0. If I do that, this dies, and I'm just left with 20. Of course, there's no 20 on the graph. Arrgh. Okay, so the y-intercept is going to be all the way up here, all the way up here somewhere, all the way up here at 20. Okay, now again, I'm going to use that symmetry if I need to say, well, if that went over, looks like 2, then if I go over 2 from this side, So 1, 2, if I go over from this side, it should go all the way up to 20 as well. There should be another 20 up here too. Okay. All right, so let's sketch that in. So it's going to start all the way up here. It's going to travel all the way down. We're going to try to turn a little bit before the end, and then we're going to head back up again. This is not my best sketch ever. And we're going to put those arrows at the end to say they continue to go up and out. All right, so if I look at domain for this one, domain are x's, so look sideways. It does still look like we go everywhere. So positive infinity, negative infinity. So in interval notation, negative and positive. The range is going to be the y's. So if I look this way, again, looks like we go down as far as -7/2. No, what is that? Let's try that again. Goes down as far as -9/2, and it goes up to infinity. Okay, so range are the y's, so -9/2 to up forever. Okay, this one again has a minimum point, okay, and its minimum value is going to be that same number, -9/2, and the minimum point is going to be the vertex, which is -7/2, -9/2. Cool. All right, here's one more, and this one starts with a -x. That's not a big deal. We'll still do the same exact thing that we did before. We'll identify a equals -1, b equals 4, c equals -3. Okay, to find the vertex, we're going to use that -b over 2a formula. So -4 over 2 times -1 is going to be 2. Okay, then I have to plug in a 2. So y equals negative parentheses 2 squared plus 4 parentheses 2 minus 3. Now look at the way I wrote that. You see how the negative is on the outside of the parentheses, right? Remember, when you're plugging things in, whatever that letter is, and only that letter, goes in parentheses when you're plugging in values. So the 2 gets squared first, the minus happens after the square. So we're going to end up with -4 plus 8 minus 3. So that's going to be a +1. So we've got a vertex of 2, 1, and an axis of symmetry of x equals 2. Those two always go together. So vertex of 2, 1, and axis of symmetry of 2. Cool. All right, on to the next thing. Next thing is to set the y's equal to 0. So if I set the y's equal to 0, I'm going to get 0 equals -x squared plus 4x minus 3. I don't want to try to factor this with the negative out front, so I'm going to actually pull out a -1. I'm going to undistribute a -1, so I'm going to get x squared minus 4x plus 3. I'm going to try to factor this one. So two numbers that you know multiply to make 3, but add to make -4. This one will multiply to make a 3, but it won't add to make a -4 unless I make them both negative. And this negative run is just impossible. You cannot set 0 equal to -1, so it's gone. I'm just solving the other ones. So x equals 1, x equals 3. So on the x-intercept, we've got 1 and 3. Ooh, cool, look at that. If the vertex is the top point now, that means it must be opening down. So remember, it's that first number. If it's positive, it's going to be opening up. If it's negative, it's going to be opening down. All right, on to the next thing. We set x equal to 0. That should be the easy one. So if I plug that into the equation, I'm going to get I'm going to get y equals -0 squared plus 4 times 0 minus 3 is just going to be a -3. So I know y equals -3 is going to be where it comes over here. So by symmetry, right, it looks like it takes me 2 steps to get to the vertex. So I'm going to go over another 2 steps. There should be another point over there. And I can go ahead and connect those. There we go for the parabola for that one. Okay, so looking at domain, if I look from left to right, there is a graph everywhere. Remember, domain is x's, range is y's. It's alphabetical. D first, then y, then range, x first, then y. Okay, so when I go to do range, looking at the range this time, now it looks like it only goes up as high as 1, but it goes down to -infinity. So it goes up as high as 1, goes down as far as -infinity. So in numeric order, -infinity to 1 and brackets because there's actually a vertex there. So in this case, we have a maximum value, and the maximum value for this one is 1, or I could say it has a max point, and the max point would be 2, 1. Okay. All right, so we've got 2 word problems to do here. So you have 100 feet of fencing to build a rectangular enclosure that borders on a river. So we are building this part next to the river, and we're going to use the river as one of the borders so that we can save on materials. Okay, find the length and the width of the plot that will maximize the area. Maximize the area. And then it says, what is the largest area that can be enclosed? Okay, so let's take a look at this. So I'm going to need 3 different things. Now it looks like it's a square, but it doesn't have to be. It could be anything, right? So what could I do with this? So what is the one thing that I know about the 100 is that if I add all 3 of these together, that's going to equal 100, but they're not all 3 equal. But I do know that if this is X, then this is X, right? Those have to match, okay? All right, so if I make this one Y, do they tell us anything about the other one? Find the largest area, no, it doesn't. Okay, so if I do X plus Y, I will have used up all 100 of the fencing, okay? So again, I had a choice. I could flip them around and make this top one Y and make the side one X's. I chose to use more X's and less Y's because I know they're going to go towards an equation, okay? So this is going to be 2X plus Y equals 100, or I could even say Y equals negative 2X plus 100. Okay, all right, so there's one of my facts, is I have that one. The second one is they're telling me to maximize. So maximize means we're probably doing a parabola or a quadratic or a polynomial. And to maximize, I'm going to have to find a vertex and see how that works, right? So how do you get to area? Well, you're going to do X times Y equals area. Okay, so maybe it didn't matter which one I made a Y. Okay, but X times Y equals area. Now these are 2 different equations coming from the same problem. We have the 100 that's getting from adding the variables together. We're getting an area that's from multiplying the area or the measurements together. We need to merge these. We need to make these one big equation. So I'm going to use substitution, and I'm going to use all of this Y is going to go in right there. Okay, so let's see what that looks like. So instead of Y, I'm going to take what it's equal to, negative 2X plus 100 equals the area. Okay, and then look at that. If I distribute, right, I get a quadratic equation. I get negative 2X squared plus 100X equals A. And if you're used to having the Y on the side, then we'll put the A over on the side. Okay, so let's see, I don't see an extra number at the end, which is great. Okay, so if I want to graph this and I want to find where its vertex is, I actually have a couple choices. Take a look at this. Okay, in this format right here, it was already factored for me. I just have to replace the area with 0 and go and factor it and find the x-intercepts, right? But I actually want to find the vertex, and that is not vertex form, and it's not intercept form. Well, it actually kind of is intercept form. So I could either find those 2 intercepts and find the halfway point, or I could go back to my quadratic formula part that gives me vertex and use negative b over 2a. So this would be a, this would be b. I'm going to do negative 100 over 2 times negative 2 is going to be 100 divided by 4, and I know that's a quarter, so that's a 25. Okay, so what do I know right now? I know that the vertex is going to be a 25. Okay, so I know that's going to be a 25. What do I do if I want to find the y value or the area of this one? Well, again, I have a choice. I can plug it into either one. If I plug it into this one, I'm going to have to square it. If I plug it into this one, I'm probably going to have to work with a 25 and something else anyway. So let's go ahead and we'll plug it into the bottom one just to make it as painful as humanly possible. 25 squared plus 100 times 25. So this is 2,500, and this one I'm going to have to square first and then multiply, so I'm grabbing my calculator, people. So 25 squared equals times negative 2 equals negative 1250, and then I'm going to add 2,500 to it, and I'm going to get the y value of 1250. Now remember, I'm calling it x and y, but in our quadratic equation, it really was an x and an a, right? X was this distance right here is a 25, this distance right here is a 25, and we know that the area is equal to 1250, right? So I haven't found the other dimension of the fence yet. I would have to go back into an equation that had a y, like one of these up here maybe, and I can find out what the y is. So let's see what questions they want me to find. What's the largest area? Okay, well, largest area would be when x is 25 and when y is how much, right? So we want to find that area. So I think it's the 1250. Did they give us units? They did. They called it feet. So I'm going to call that feet squared. Okay. And again, what do I know about this one? Well, I know because it's negative, it's going to be a parabola that opens down. And since it opens down, it's going to have a maximum point. So that matches with their word maximum. So we're good there. Okay. So then when they say area, I just know I just have to find the y value in that quadratic, which is the area, and write that down. And then they said maximize by hand, and they didn't ever say, no, they did, darn it. They did say find the length and the width. Okay, now length and width in this picture are interchangeable. So they just want to know what are the two dimensions. So we've got 25 feet, and what's this one going to be? Let's go find it. So if I want to find y, I'm going to put in two x's. So that's 2 times 25 plus what equals 100. So that's going to be y minus 50. I think y is going to be equals 50. I think it's going to be y equals 50, right? So if I do that, it's 50. If I move it over, I subtract from 100, I get 50. I think y is going to be equal to 50 feet. Okay, I did a little bit of that in my head. I didn't show absolutely every step. I'm running out of room. Okay, so I think the dimensions are going to be, so let's answer it. So the dimensions are 25 feet by 50 feet. And the max area is going to be 1250. And it's going to be square feet because we multiplied feet times feet to get there. So it's going to be square feet. Okay, so I wrote it on the top. Okay. All right. Last one, and this one we're gonna make fun of Miss Mitchell a little bit. Hey, you know it was her birthday on the 18th, right? So maybe she'll show you my video instead of doing her own so she can take the day off for her birthday and actually celebrate with her family. Let's hope. Let's hope you're watching me if you're in Miss Mitchell's class. All right, so be nice to her. All right, so Miss Mitchell wants to build a playground for her kids. Now she has 4 kids. That is a lot of kids to wrangle. And when they were little, man, was this a thing. Okay, we used to hang out together. We still hang out together. She's still one of my best buds. All right, so, but some of the kids fight too much. So she has to separate them into 2 sections, right? So she has 120 feet of fencing, find the dimensions of the maximum area. Again, so it's gonna work just like we just did right there, except now we've got this extra piece of fence right here. All right, so if you know anything about her family, Charlie is the baby of the family. So he's pretty chill, so is Adele. Adele's favorite thing is like reading books. She's like so cute. Now, DC and Katie, they're awesome too in their own way, but they are not quiet people by any stretch of the imagination. So she's giving them more room to run around because that's what they need and because they're a little bit crazy, all right? So as I'm doing this one, I'm going to choose that I'm going to make all the vertical parts of the fencing X's, and I'm going to make all the horizontal parts of them Y's. And actually, just for fun, let's make it a different number. Let's make it W's. Okay, all right, so let's go and see. So she has 120 feet of fencing. Do I really want 4 W's? I'm gonna say I probably don't want 4 W's. And I made another mistake trying to tell you all about Miss Mitchell's life. I know that all the X's have to be the same length, right? Because they're a rectangle. And this has to be the same length. So I should be labeling this whole thing a W. If I labeled each individual part, that'd be saying that they're all the same length. And they're not. We're giving DC and Katie more room to run around probably, okay? All right, so let's start out with that. We are using 120 feet of fencing. So that is 3 X's added to 2 W's should equal 120. Okay, there's our first equation. But they said area, so that's my next one. So I want to do area equals, and area is going to be X times W. So I need to merge these 2 equations together. We're going to use substitution again. You decide, do you want to solve for W or do you want to solve for X? I'm going to solve for W. So I'm going to get 3x equals negative 2w plus 120. And then when I solve for x, I'm going to divide by 3. So I'm going to get negative 2/3 w. And when I divide 120 by 3, I'm going to get 40. So I'm going to plug this x into here. Okay, so let's see what that looks like. So now I'm going to have area equals parentheses, negative 2/3 at W plus 40 times another W on the outside. All right, so if I want to distribute this, I go to standard form. If I leave it right here, I'm actually in vertex form, right? I'm actually in intercept form, not vertex form. So which way should we do this? So I'm going to go ahead and distribute it. I'm going to get negative 2/3 W squared plus 40 W. So this is definitely a parabola opening down, parabola because it's a W squared, right? Down because it's a negative at the beginning. So let's go and see if we can find our vertex. So vertex is going to be negative B over 2A. That's going to be, A is negative 2/3. B is 40, so we're going to be doing negative 40 over negative 4/3. Miss Mitchell, what is she doing to us? She is torturing us beyond belief. Fine. All right, so this is going to be negative 40 over 1 divided by negative 4/3, which is the same thing as multiplying by 3/4 with it still being negative. So those 4's are going to cancel and I'll get negative 30. Whew. Actually, I am back from the future because I saw that there was a mistake later. So let's see if we can find out where this is. So I originally said negative 30. It's really positive 30, right? And that is going to be our X value of the vertex. Okay, so then the next thing that we need to do is we need to plug it back into something, right? So what do we plug it into? So let's go and plug it into, I'm going to choose to plug it into this factored form for area instead of the distributed, because I don't really want to square W squared. And if I use that equation, they're both equations for area, right? One's just distributed. So I'm going to do area equals negative 2/3 times 30 plus 40 times 30 again. So if I do that, this will become negative 20 plus 40 times 30. So that's 20 times 30, which is 6 with 2 zeros square feet. Okay, so again, because this is a negative right here, this is going to make a parabola that opens down. So the vertex right here is going to be at 30, 300. Okay, so remember, what did we solve for here? We solved for the X value first, right? Did we solve for the X value first? Let's go see if that works. Okay, let's go check it. All right, so if X is 30, I get a 30 here, a 30 here, and a 30 here. And they're saying that this total amount is 600, right? So I'm going to go back to this original equation right here and say, which one did we solve for? Well, we had a W, remember? So what I actually found was the width, not the X's. So let me go back and fix that. So these are not 30s. These are 30s. And if I plug them back into that equation, we're going to get 3 X's plus 2 30s equals 120. So that's 3 X's plus 60 equals 120. 3X equals 60 if I move the 60 over. So X is 20. So these are going to be 20, 20, and 20. Okay. All right, so what did they ask? They said, find the dimensions of the play area and find the maximum area of the playground. So here's the funny thing. Notice back, I had to stop the video for a quick second. So let's go and finish this up. So we already have the max area. We already have the entire dimensions. So we have answered their question. So find the dimensions, X and Y. We did X and W, same idea. And then it said find the maximum area, 600 feet squared. That is it. I am sorry these are so long. Hopefully they'll get a little bit faster. And again, don't forget to tell Miss Mitchell a belated happy birthday. All right, bye you guys.